The Rockies are right over there. Don't just go to the conference. Go and see the Rocky Mountain National Park. Go hiking up at Bear Lake or something. Don't do what I did, which is just to come for the conference. Go and see the area.
Alrighty, everybody. Thanks for coming here to Graphics Programming with SDL3. My name's Mike Shah, and thanks for joining this session on our last day of CppCon. It always goes by so fast. And again, thanks for joining. This is part of the game dev track here. Thanks to Guy Davidson for helping organize these tracks this year. It's been a lot of awesome talks. But today we're going to learn about SDL3 and a little bit of graphics programming. This is sort of aimed at a beginner audience. If you haven't done any graphics programming, or maybe you have done some, maybe in an engine, but you want to see how to do things from scratch. So just quick show of hands. How many people have done some graphics programming previously? Okay, good number of folks. How many folks have used SDL 2 or 3 or 1.2? Okay, so maybe about half the audience here. So we're going to see some new stuff. We'll see some old stuff. And maybe we'll just see some stuff as to why SDL3, I think, is a good API to even upgrade if you are using SDL2. So here's a little bit about me, the abstract. Hopefully you read that. The note we're talking about. Again, my role at CppCon has been doing some back to basics and software design organization, and I teach. I teach a lot of game programming, computer graphics during my day job as a professor. You can find a bunch of my content on YouTube if you want, if you like this C++ stuff, specifically SDL3 stuff. And I'll show or link a few of the videos. These slides will be posted. The code from these slides will also be posted as well. So check those out. I'm always adding to that video series. And of course, more C++ stuff. So okay, enough about that. Getting into the talk. And again, the source code. If you Google my name, Mike Shah C++, or Mike Shah Yale, or something like that, you'll find my website. Give me about an hour after the talk, and I'll post slides there. Otherwise, they'll be in Discord for those attending currently. Okay, well, quick question to folks. Since we're talking about graphics and a little bit of games here, how many folks got started in programming because they wanted to make games or thought they were cool? Yeah, again, this audience, a lot of hands going up. That's my story too. Still hasn't really stopped. I just think it's a really awesome industry to be a part of. Just as a brief aside, part of the motivation of this talk is in some ways talking just a little bit about the business of video games. I'll give you the short spiel. The game industry, has its sort of cycles that it goes through, but largely speaking, if you draw a curve from the 80s or 90s, 2000, 2010, it's a growing industry, right? And more folks are getting involved, whether that's at the sort of developing a game by yourself or maybe part of a team of 100 or more people. We're seeing more games coming out every day. I think there's on the order of hundreds of games sometimes released to the Steam or Epic game stores or itch.io, these types of things. So it's a great industry to be a part of because, of course, it's very fun to work on games and the art and so on. But the little business side thing that I wanted to mention is if you use a game engine, so a tool that helps you build games, one like Unity 3D, Unreal Engine, maybe even something in-house, Godot, all these different engines. Oftentimes you will find something that looks like this picture on the right here, meaning you have some dialog window, you've programmed the game, you built some tools, and it's got a little export button here that says, okay, I want to export out my game to Windows, Mac, and Linux. Great. Push the button, you've got a binary that runs on Windows, Mac, and Linux, or it's hopefully packaged up properly to do that. Maybe mobile, maybe web, maybe game consoles, and so on. So, why is this an important feature? Well, if you're building a game going through all this effort of doing so, it's nice if you can deliver to customers who own Windows, Linux. You can see I have a Linux machine here, so I can play the game, then your Mac friends, Windows, console players, or whatever. You grow the market, so to speak, of where you can deploy your game to, or at least that's the idea here, right? So if you're a small independent developer or even a large studio, this matters, right? To be able to run software on multiple platforms. Okay, so as a programmer, maybe if I'm actually programming the system, different platforms have different capabilities, different APIs, different ways to program things. So maybe I write code that looks something like this, right? And this is some actual code I grabbed from SDL, which we'll be looking at, where I have a bunch of these else if blocks in the preprocessor that do stuff for one version of a console. These are some older consoles here, the PlayStation Vita or Nintendo 3DS. But all of a sudden, all of your code has these pound if, else if statements, and that's a lot to manage, right, per platform. Okay, so that's one way that you could do things. Maybe we can graduate and do things a little bit smarter because we want to support all these platforms in our code we write. And you have an if-def for the Windows version, include the header for the Windows implementation of functions, or some way to potentially divide up the work here. And again, there's different ways you could leverage build systems. There's been lots of great CppCon talks otherwise about cross-platform development, but maybe if you're starting out, this is something that you would do. And the bolded thing here that says, well, if only there was a well-tested cross-platform library that handled all this for us. And there is. And that's what we're going to be talking about today. So that's the exciting, the good news today, that there are, not just one, but many libraries that try to solve this problem. So you can focus on building your game, your media application, or whatever without having to necessarily write all that support code that's specific to Windows, Linux, Mac, PlayStation, whatever. You just have one function call you can kind of keep track of. Okay, so today's goal, again, is to show you how to use the SDL3 Simple Directmedia Library graphics library. I'm going to show a bunch of examples. I'll do a few live examples as well, meaning just running some code, because why not? It's kind of fun to see some graphic examples. But we'll kind of, again, take you start to finish with SDL. So again, Simple Directmedia Layer is what SDL stands for, and it's a C-based library. So I'm going to focus more on the graphics part today, but SDL has multi-platform support for many things. So probably the big thing, again, graphics, which means things like just displaying a window that you can draw something to. It's also got audio, input, meaning keyboard, mouse, joystick, whatever device you plug in, stylus, pen, touch, etc., is all supported. There's webcam that works for multiple platforms and so on. So it has a lot of stuff that I'll list out. There's even thread libraries and file system stuff that you can just use in a cross-platform way with this library. Speaking of the platforms, SDL supports, again, I've listed a bunch of them here. Pretty much any major platform that has games running on it probably has some port of SDL available, whether it's been done in-house by the company or is just publicly available. So that's pretty cool. It's even available for the web, which I'll again show a brief example of. SDL itself was born to solve this problem. So giving some credits to Sam Lantinga, who's over at Valve, who was basically doing a project of trying to run this old game with a emulator basically, and wanted to be able to run it on Mac. That's how this was born. So again, I always say, good software is usually born from solving a real world problem. So again, that's where SDL comes from. So Sam Lantinga and Ryan Gordon, who's also listed, who does a lot of ports of games, are two of the developers who have really led a lot of the effort. And they have some talks you can see if you want to learn more about the history of the project. And as mentioned on that previous slide, it is 27 plus years old at this point. So it's well known, well used. SDL is also open source, so you can see all the implementation. There's no hidden details, which is great. Again, because if you're writing code, you want to know why something's working or why there might be a bug, you can just look at the source code. And I've even had students and myself submit pull requests and fix things or try to add features. So it really is a long-running open source project with quite a nice history. SDL is C-based. So the good thing about that is we know C is currently the lingua franca, let's say, programming languages. So pretty much any language that can talk to C can talk to SDL. So whether you're going to invest time in SDL with C++ or another language, it's all the same function calls that you're going to be using. So again, a very nice reason to look at SDL. And again, like I said, it's got a long history, so it's industry proven by from large studios to independent game developers that are using SDL. So again, maybe you'll use this at your work, maybe some of you are using this at work, and so on. SDL also is a very, because it's being tested and used at these studios, it tends to be very stable, both in terms of things like getting bug fixes, but also ABI stable. So the functions are what they're going to be called. You don't have to relearn something or worry that it's going to change underneath your feet and you're going to have to keep updating. So that's another reason why I really like SDL. So the version we're locked in at now, 3.2, we can add features, but the features that do exist there are going to be the same function calls and be available. And SDL tends to support for about 10 years at a time. So we got SDL1 for about 10 years, SDL2 for another 10 or so years. I expect SDL3 will be a similar cadence. Now SDL itself, again, as mentioned, we're going to talk about some of the things it's going to do, like provide a window for us or draw some graphics, but it is not a full game engine, so to speak. We're going to sort of have to build up those abstractions ourselves if we want to display something. So as far as where SDL sits, if you want to, in this picture on the right here, SDL basically is the abstraction layer for those operating system calls for setting up a window, or those operating system APIs for doing that. And then you'll build the abstractions, data structures for building your game or ultimately game engine. SDL does, and where we'll start our journey, provide a lightweight 2D abstraction though, however, where you can do things like draw images to the screen. And honestly, that's enough if you want to start building games. You can just use that as is. It provides enough for you to get started. But if you want to add more stuff or more features or dive into the computer graphics world, that is also what SDL leaves open for you. So again, SDL is a library that provides this platform-independent way to do all these things like set up a window, do graphics, threading, file handling, and much, much more. And for those of you, since a bunch rose their hands that they'd use maybe SDL1 or SDL2, this is one of the advantages if you're thinking about going to SDL3, and that it's handling more platform-independent things like the webcam, touch display. If you have high-resolution displays, just having a way to handle all of that is very, very nice, which the previous APIs did not provide. Now, there are other related frameworks. These are also great. I've used a bunch of these, SFML, GFL, Qt, and so on, that also achieve some of the similar jobs. So depending on what you need to do, you might also explore these. SFML is one to note that's C++ code base. So take a look at those and see if they meet your needs as well. All right, but let's get started with SDL. Now that we know a little bit about what it is, with the installation and setup. No, I'm not going to download it in front of you and spend time doing that. But I do have a bunch of videos on that, again, for Windows, Linux, Mac, Windows with Visual Studio, Windows just on WinGW, and so on. If you read the comments for my videos, they'll say, hey, this guy's just installed SDL 8 times. Let's actually do something. But the point is, it's well supported on many different platforms. And the SDL wiki has a bunch of instructions there. So you could follow setup there. Package managers, tools like Conan, VC Package. Again, you'll find usually the latest build of SDL there as well if you want to just do whatever the commands are to find SDL3. And again, it's highly available because this is a library that's been around for a long time and it's been well supported. Okay, so with that in mind, let's go ahead and take a look at a Hello World SDL program. Okay, so we'll look at it here in C++, and we'll even run it. Again, I said I'll do a few live demos. Excitement, and here it is. Okay, so what you'll see, the blue is again just comments, and the white is the function calls. It's 6 lines of code, not too bad. So let's actually just run it so we can see what this program does, and then I'll explain it. Let's see here. So here it is. Let's just go. I'll just show you the minimal version to get rid of some noise here. All right. So we initialize SDL. We create a window here. We're going to delay for 3,000 milliseconds just so we can see something. And then I'll destroy the window and quit. Okay, so that's it. I'm just going to pop up a window for 3 seconds. So let's do that. G++. Here's my minimal example. Just so you can see here the program. I'm going to do what I always do, just intentionally. I'm going to try to build it. Oops, mistake. All right, we got to link in SDL here, SDL3. Okay, and that's it. Okay, at least on Linux, pretty easy setup here. Run the program. There's our window here. You'll see now it grabs some of the background here, but that's all that's expected. So now I've got a way in 6 lines of code on Windows, Linux, Mac, name whatever platform you want to launch a window and start doing some graphics stuff. Now we haven't done anything totally interesting at this point, right? We just have a window that pops up and looks like it grabs some memory behind the screen there or something, but that's it. Kind of as easy as it gets. If you've ever written any platform-specific code, things like using the Windows API or whatever Mac's got, or X11, or these types of frameworks, that's often more lines of code to get that up and running. But now we have it there. So magic. That's magic to me. So that's all it is. Again, the compilation process, pretty simple. On Linux, it could just be, depending on your paths, how they're set up, as simple as linking in SDL. But of course, I usually use package config and these types of things to support Windows and Mac for me. Okay, there's some instructions on compiling and linking. Maybe if you're a student watching this and want to understand how that works. The other thing that I'll note here is, I showed you sort of the traditional program with a main and then a couple of function calls. SDL also has a callback API, so you can do sort of a different setup, which is often more friendly if you've done web development or for mobile devices. That's also available and supported. One other quick example before we jump further is that there's you can also target the web with SDL, because again, it's a generally easy C-based library. So it's supported with the mscripten compiler. So again, I have videos on that. But what's really cool is if you go to the examples, and we'll just click on one that's kind of compelling here, like a rotating texture, right? You can see your SDL program running here on the web. So if you want to show it off or distribute it that way. And then most of the time they have the source code here as well, which is just, like 40 or 50 lines of code. So pretty neat, nice way to explore SDL and even think about sharing your code. Okay, so with that in mind, let's look at some of the basics of using SDL, the sort of structure. Right, so here was our minimal SDL program. Again, that pops up a window for 3 seconds. We probably want to do more than that, though. Right, if we're going to build a game, be able to actually interact with our application here. Now, again, little aside here, just a little note before we get further. I'm shamefully omitting all the error handling behavior. But most of the SDL functions the API is you call the function and it'll return true or false based off if it succeeded or not. So that's kind of the way to check for errors. So you'll see if, call SDL init, or if do anything, and it'll return usually true or false. You can log your errors or call the SDL get error function, and that'll try to return more information. So there is a nice error handling in the C sort of fashion way of dealing with things here. But I'm going to admit that for the slideware. Okay, so anyways, back to our minimal SDL program. Let's try to do something a little bit more interesting. So we want to start handling some events. So if people press a key on their keyboard or otherwise, just in general, keep our application running, right? A game or a media application should be running forever in an event loop, basically. So I want to talk about this union here called SDL event. Okay, so in this example, now I'm going to add this struct here, SDL event. And you'll see highlighted in orange, basically a infinite loop, while 1 or while true. If you want to do this in the C, or maybe true for C++ here, way here. And then within that, you'll see that we have this SDL pull event here, which basically grabs a event that might have happened, Maybe I moved a window, moved my mouse, clicked a button on my keyboard. That's the type of thing that's returned in this event. And again, remember C-style API, so you're going to see things like SDL pull event at line 21, and then it's returning the output through a pointer, so sort of as an output parameter in the function, and populating the event with what happened. And then we can check in our conditionals if this type of event happened or if this other type of event happened, and so on. Okay, so that's the idea here. And internally, SDL is managing a event queue, so first in, first out event queue that as I do things, again, pressing buttons, moving my mouse, etc., then it will process those one after the other. And those events will also time out after some period of time, so your application isn't totally stalled, but that's basically what it's doing. Okay, just to give a little insight there. Now SDL event, this actual struct that I have is a union. Again, we're in C land, so there's no tagged union or variant or anything here, but it is just a regular good old union. And this is what it looks like, right? Don't have to read all these, but you can see that an event can be lots of different things, like a keyboard event, moving a mouse, resizing the window, touching if you have a joystick or something, all these different things here. So basically, just works with this union type. And you query what the actual type is, notice the field of within this union is just a uint32. Well, it's really small, so I'll just read it for you there. But that's, again, how you tell the type. Because, again, we're in C land, there's no real polymorphism or anything here. So just as an example, which sometimes this can take a little bit getting used to, just navigating that structure here. If I wanted to check if I pressed a button on my keyboard, I would check for the event.type, and there are a bunch of enums that are defined in that giant list. So again, just zooming in, I could search for SDL event underscore key underscore down, and that must be some keyboard event here. And then I will access within my union this thing as a keyboard event. Okay, and then you can explore the SDL underscore keyboard event struct that'll actually be returned and access the various fields. Okay, so it just takes a little bit of navigation. If you haven't done that, that's the basic idea there. Okay, great. So with that, we have a windowed application. We can respond to events, key presses. I'll test it out in a moment here. Let's start to get to the exciting stuff and add some graphics. All right, now, again, just to give a little primer on some game terminology. I mean, 2D rendering and graphics is a pretty big topic. 3D is probably even bigger, right? It contains all that other stuff with it. But let's at least get some of the basics here, just to carry you along, and they can see how it maps to the SDL terminology. But basically, there's two different ways that we could draw graphics. So on the left side, I've got what I call raster-based graphics, which just means I have pixels. Some artist came and individually drew every pixel of this smiley face here, one at a time here, at a specific size here. So that's on the left. And on the right, I have vector-based graphics, which means this scene was created with mathematical function. Okay, a line starts from here and ends at this point here. Okay, so that's a difference. SDL supports both. They have sort of trade-offs depending on how you want to draw your graphics. Right, so on the left side, the artist painted every pixel at exactly this size, but you probably can't scale it so much. On the right side, maybe not as expressive, but more compact representation of what you're trying to draw. Okay. And we have different ways to represent these different ways of drawing. On the left side, we'll start with SDL underscore blit surface. That's a function that basically says, hey, copy those pixels from here on the smiley face and paste them into our screen. Okay, so blit is just another word for copy, or memcopy if you want to think about it that way, for copying your pixels onto the window. And on the right side for the vector graphics, it literally is just calling SDL render line from this starting location to this ending location. Okay, just on a Cartesian coordinate system conventionally. Okay, now if we want to display graphics to our screen and do something more interesting, like start having animation, we just call these functions every iteration of our loop. So basically, if I draw my pixels, and then the next iteration of my loop, I advance those pixels to some other different location, right? That's how we get to animation. So it literally looks like this flip book here that we have where we're blitting new pixels to our screen every time. Okay, whether I'm doing that with the blit surface or the same idea with just rendering lines in different locations. Okay, and it should look something like that. Okay, but again, we are in 2025. We have nice GPUs in most of our devices, even our phones. So let's use our graphics card instead of just blitting or mem copying pixels to the screen. And there might be reasons to do that sometimes, but let's take advantage of our hardware that we have, right? We paid good money for it. So rather than just doing effectively these CPU operations of blitting or mem copying, what we want to do again is take advantage of our graphics card on the hardware acceleration. Okay, so that's how we're going to speed up our drawing. So our basic strategy is going to say, hey, let's use our graphics card to copy some pixels into a rectangle, or we usually call a quad, and then we'll have those pixels in GPU memory, and our graphics card is really good at drawing things in parallel to the screen. So that's the idea. Okay, so this is going to be the basic setup for what we're going to do to take advantage of our graphics card. So in 3 slides, the first step, we're going to take some pixels. Let's say, again, an artist worked really hard to draw this, our art or a character. In these pixels, again, maybe they're a bitmap image of sorts. In SDL, we call these SDL underscore surface, and that is what's representing an image. That's a width and the height, the pixels, the actual raw pixel data, as well as maybe some other information like the format of how those pixels are arranged, but that's the basic idea. So SDL surface, you can think of kind of synonymous with image, okay? That's on our CPU. Then our next operation is going to say, hey, we've got this memory on our CPU. Let's take that surface and create a texture. And a texture is the thing that lives on the graphics card, or the pixels that have been copied over in the graphics card. So when I say SDL underscore texture, that's something that exists on the graphics card. Okay, that's the idea. And sometimes people use the term pixels for CPU and texels for what's on the GPU. Just kind of depends. If you're just starting with this stuff, just try to keep track of surface on the CPU, texture on the GPU, that's fine. Okay, and once our memory's on the GPU, then again, our graphics card can draw this stuff really fast for us. And again, the textures that we're drawing in 2D games, they're just quads. Everything's quads, even if it doesn't look like it's quads. Maybe we're omitting some pixels here, but here's just kind of a nice breakdown. Again, the top is our final scene with the textures. The middle is the wireframe, so omitting the detailed pixel information, but just showing that there are quads here. You can kind of look at the wheels where you see just a quad there, quad on top, and then the overlay, of course, with the texture wireframe image. That's the basic idea, right? And we can do some tricks. I'll show briefly a code example where you can figure out how do I omit pixels of a specific color so that I can just draw a wheel. But at the end of the day, it's all just rectangles or quads. Okay, and then again, this is just our sort of 2D engine. Nothing stopping us from adding a third dimension from this, but again, we're sort of living in 2D land for now. We can still model the Z component in here, or I guess that could be a controversial thing in graphics. Is Z up, down, forward? Anyways, depends on your coordinate system. All right, so let's kind of keep moving along here and figure out, now that we have some basic terminology here, what's an SDL that gets us the hardware acceleration. Okay, well, the first thing that we're going to do is create this thing called a renderer, or I'll return this object SDL underscore renderer. And that's the object that kind of keeps track of all the stuff that's going on our graphics card. And it's going to hold the state regarding the types of textures and stuff we've uploaded, and just how we're going to draw things to the screen. Okay, so that's SDL's abstraction for us. We might call this like a context that holds, again, all the graphics state. I will note there is a software rendering version of this, so we still use textures and stuff, but if you don't have a graphics card for whatever reason, you can still do everything on software, which may be useful as a fallback render or just in other domains. Okay, so how do we actually use this? Looking at a little bit of code here, just highlighting a few of the key parts here. So again, we would create a renderer or have a pointer to one. And then at line 17, we'll create a window and a renderer here. Okay, so we'll populate again as an output parameter there, the renderer and the window object that we create. In this particular example, we'll see what type of renderer it gave us. So I'll run this in a moment here. And then in our loop here, this final orange block here, we're going to see that we're going to clear the renderer, draw a full color, it's just going to be a black window, and then we'll present what was drawn. Okay, so let's actually just run this here again. Example number 3. So whenever you want to follow along with these later on, you can do that. Let's do this here. Run. Okay. So there is our I guess I changed it to red here. And you'll see, importantly, the printout that came here, the renderer that I selected was OpenGL. Okay, so that's the graphics API that, for whatever reason, it's sort of defaulted into. Okay, so OpenGL is an example of a graphics application programming interface for hardware-accelerated graphics. Okay, and again, you might have heard of ones like Vulkan, Metal, Direct3D, which we'll get to. Okay, and then if we want to combine all of this with what we learned previously, a little bit more of a compelling example with handling some key presses, you can do some stuff like drawing a different background color. So again, this would be the next sort of progression here. Example number 4 here. So we have events, we have rendering, and if I press a key here, it'll change the color of the windows. Awesome. Okay, so we're moving right along. All right. Now, SDL is also doing a few other important things for us, just as an aside here. So what I've highlighted here, right, the basic process is to clear our window, so sort of wipe the canvas, give us a blank slate to paint on. We set up whatever our drawing commands are. So whether that's where I want to draw a yellow or a red background, like I was flipping between, depending on what key press I did. And then we present after all of our drawing commands to the renderer. It says, hey, here's all of our updates. And basically that's what's shown on the screen. So SDL will do this thing for us called double buffering, which basically means it's painting or setting up the background image in a back buffer. And then when I call present, it flips whatever was in the back to the front. And then while that's being done, we can start painting more stuff in the background. Okay, so that's the idea. If you hear this term double buffering, it tends to make our rendering a little bit smooth from one frame to another. And you could do other fancy tricks like triple buffering and so on, but this is the basic idea here. Okay, so you can read a little bit more about that if you want a reference or wonder why that's the general pattern. Okay, and again, this is important for us for animation and making our applications just look a little bit nicer. If you've ever seen a laggy video or laggy video game, and most likely they're still using this, maybe it's just running slow, but again, this is one of the things that helps. Okay, so we're adding more stuff here to our SDL application, and just a little bit of abstraction here I think will help. So what I tend to do in my SDL graphics applications is create maybe some sort of structure like this, SDL application, try to keep it pretty minimal. But basically I want to just encode all the state that I'm going to start creating in some struct. Okay, this does a few things, right? My main function is nice and clean, right? We don't want to write all of our code there. But now I've got this, all of my state is basically the data members here. You can take this further and say, okay, I'm going to take all of my member functions, maybe wrap that in some app state or graphic state or something. So you have that available. But again, this might be something as you start building SDL applications to consider doing. It can also make your programs a little bit more testable. Meaning I can parameterize, how I create this object with different window resolutions or something, or different other settings that you want to pass in. And then when you start getting into things like building your own event queues, you can pass in, a series of events to test things out. So just a little advice there, and you'll see that in the examples going forward or if you look at the code later. Okay, so with that brief recap here, we've learned about textures, surfaces, and a window. And again, I'm always linking the SDL documentation because it's quite nice. So we'll want to, again, create a surface, something to hold our pixels. And so from some maybe bitmap image that we'll load up. And again, here's all the surfaces, a width, a height, pixels, some additional format information as well, depending on how those pixels are arranged. I tend to think of them as red, green, blue, but you could have all sorts of different formats there. And again, we want to create a hardware renderer. So again, this is just a link or a sort of for your information on the rendering API here. Okay, so I'm going to keep going through that. And then the texturing API. So importantly, there are a few functions in here. I'm just going to, again, show you in the code here, but the documentation lists them all out. For otherwise creating a texture from a surface, which is, again, going through that step of saying, hey, I've got a bunch of pixels in this surface, and now I want to upload to the graphics card and create a texture. Okay, so that's going to be these first and second functions here that are important. We'll just use the second one, but you could also create a texture and populate itself from any memory that you have. Okay, and then importantly, we have our rendering functions, which is, again, all of the state in the hardware accelerated rendering that sort of manages for us and does this idea of clearing the screen, drawing our graphics, and then ultimately presenting our graphics. Okay, and that's just a abstraction over Direct3D, OpenGL, as we saw in my case, maybe Vulkan, Metal. SDL will choose what it thinks is reasonable. Well, I think by default, most of the time, it's using OpenGL because that's the most widely supported thing. Okay, so again, I already showed you render or how to clear. I showed you present, but in the middle, now I'll show you how to render a texture. So we'll see something a little bit more interesting. Two other important primitives here, figuring out where do we want to actually draw stuff. So we want to draw like an image or a character to a screen. You'll see in SDL, they'll pass around these SDL rectangles or SDL_F rectangle for a floating point rectangle, meaning the fields representing the X and the Y position of the rectangle in the top left corner to the width and the height of that rectangle will be either floats or integers, depending on the type. Okay, so let's look at it in code, a little more exciting. So I've got this character here. We'll just call this test BMP. I don't know, this guy looks familiar, but we'll just call it that. And for my SDL application, let's just, again, to start, create a surface and a texture. Maybe we'll hold on to those. We might not even actually want this surface up here. It's just kind of going to be temporary, we'll see. So that's the first part. The second block here, we will say, okay, for my surface, I want to populate those pixels by just loading a bitmap. So again, SDL gives us this function that can load bitmaps with or without transparency. This bitmap's actually got transparency. And then the all-important function at line 25, SDL create texture from surface. And that says, okay, for a render that's going to hold on to all this state and keep track of all of our hardware accelerated stuff, populate it there from the pixels from that surface. And then as soon as I have my memory allocated on the GPU, I don't need that surface anymore. So I can just delete it, okay, at line 26. Now, again, if you're writing an engine or something, you might decide, well, I might need that later, or these types of things, which I'll mention in a footnote later. But you can basically decide. But usually, again, it's a C API. So if you create something, you'll call the appropriate destroy function. Also, just as a side note, as I mentioned, for some folks, since many were using SDL2, the SDL3 API has actually become a lot more consistent with its naming. So things are create and destroy. There used to be other name functions. So again, that's enough of a reason that I like using SDL3, or was worth the upgrade for me, the consistency in the API. Okay, so anyways, that's that. And then here's my note again, just about freeing the CPU pixels once you don't need them. Okay, so here it is, putting everything together. And then ultimately, when I want to draw this texture, the important thing, and the second orange block here, SDL render texture. The renderer, again, holding all the states here, the texture that I want to draw. The source here, we'll keep an eye on that. That's just null. That means draw all the pixels for my texture. And then the destination, which is the final parameter, that's the rectangle, which I've highlighted here. It says draw this character. The top left corner is 0, 0, and it's going to be 64 pixels by 64 pixels. Okay, so that's the basic idea. So hooray, we've got something, drawing here. And then if you can imagine, all I have to do is update the X and the Y positions of this rectangle, and all of a sudden I've got a character moving around. You can build a game here, Pong or whatever, at this point. Okay, doing more interesting things. So animating textures. I have this third parameter here that I've highlighted, which is the source rectangle. And basically what that's saying is I want to select from my sample texture a specific portion of it. So let's say I have this sprite this time with this Mario character, and I just want to select a few of the actual pixels from the texture. So then you'll notice as I change where I'm selecting from here, in the different places, Mario will animate. Okay, I go back and forth, and you can kind of see the X position and where I'm selecting from. Okay, so that was my PowerPoint copy and paste. I'll actually run a tiny demo here, just so you can see sprite animation. Let's see, I think I've got it on this one here. And so there's our little guy running around here in a sprite sheet. A few things about this demo that are kind of neat. I can resize the window. There's also some other interesting things here. You'll see as I resized it, this character preserves its pixel quality. So there are some other things you can do for the sampling. But again, this is all just SDL code, like 1 or 2 functions that does all the resizing, all the pixel sampling, so it doesn't look stretched or blurry. So again, it's just quite nice here. And then again, you'll see the available renders here, which is going to lead us into our next part. Looks like I was using OpenGL, but I've also got Vulkan on this machine. Okay, so that's a little bit nicer. Okay, so there's plenty more to look at here, but to be honest, if you wanted to start creating games with just this amount, right, you know how to animate an image, display it, and move the textures around. That's enough to get started. So, what are we waiting for? Let's have our hackathon after this. But of course, we can add some more sound stuff, scroll the textures, rotate things, move them around, and so on. But you kind of get the idea there. All right, great. Okay, few notes on this. As I mentioned, I am a little cautious sometimes with my abstractions. So again, once you know what problems you're trying to solve, you can always start adding in some of the nice things that we like about C++, things like RAII. Right, we've got this like create and destroy pattern in C. But again, we do have to sometimes when we're game programming think about the lifetime of these resources, whether that's CPU or GPU. So what I mean by that is, for a while, I used to do this pattern where I wrapped a texture and had the create and destroy. But what I found over time is you end up writing some sort of manager class, so you have really explicit control over the lifetimes. Again, maybe depends on the game or thing that you're writing. But that's just a little note before hopping in and doing some of those things. So things, think about things like the flyweight pattern. If you've seen those, we tend to like to cache resources. And again, be able to explicitly manage the lifetime. So that's kind of a nice thing with this C API. Okay, great. So that's all the the basics of SDL with the built-in stuff. Again, plenty of stuff for games here, but let's get into the new stuff. Okay, so new to SDL3 are some other functions for graphics rendering. Now, SDL3 still has, again, as we already saw, the ability to create a window, and I can explicitly say, hey, I just want to use this window, and then I want to use the Vulkan graphics API or OpenGL, Direct3D, Metal, whatever. I can just do that, and that's enough. SDL will provide the window rendering, the event handling, and so on. But at some point during the SDL3 development, the folks making this saying, hey, we already have this nice rendering API, why don't we abstract on top of this just a little bit? So new to SDL3 is the full SDL GPU API, okay? And what this provides is a abstraction layer on top of Vulkan, Metal, Direct3D. This time you're in control. Okay, so we're sort of taking away, these nice functions like SDL, render texture, and so on. We're implementing now all of what was in SDL, underscore renderer. We control the state, we control the resources, and we're using this API on top of, or this GPU API that's wrapped on top of Vulkan, Metal, Direct3D to do the calls here. Okay, so that's the basic idea. So this is again built into SDL3, this thin abstraction layer on top of Vulkan, Metal, Direct3D, 12 specifically. And these are the sort of modern graphics APIs, the APIs that are matching what our GPUs are doing, making them, again, highly programmable, highly parallelizable. So the idea with SDL3 is to give you access to that, but in a way, so again, you don't have to write specific Metal code or Vulkan. You can just maintain one graphics code base, basically. And there's even a web GPU experiment in progress as well. I don't know if that's going to land or the exact state, but I've seen it and been hearing whispers of it. So, okay, so for the SDL GPU API, it is more verbose, right? Because now we're in control, but that means we're in control, so that's a good thing. And it's still, I would argue, easier than the modern graphics APIs. There's a reason the Vulkan hello world to draw your first triangle is like 1,000 lines of code. There are reasons for that and the design. I sort of understand why. But I can do that same thing here in like 200 lines of code. That still sounds like a lot. But the truth is once you can draw one triangle or quad, right, then you're kind of done, right? We saw that at the start. Okay, so all the window event handling stuff, all of that's the same, right? We just use that as normal. So I've highlighted that in this box here. So none of our old or none of the knowledge we learned about SDL previously is wasted. But this time, again, highlighting in this box, this is our rendering code. Okay, and I'll explain some of the big ideas behind that and give you an example. So again, there is no SDL underscore renderer here. We're writing our own version of that. Okay, whatever that state and so on means. Okay, we've got to figure out how to upload the pixel data to the GPU. There's no, convert a surface to a texture that lives on the GPU thing. We do that. Okay, so with that in mind, for modern graphics programmers, there's really three big ideas or three abstractions that I like to break it down into. The first is shaders, buffers, it's the second, and the third is this idea of a command buffer, okay, which will include our rendering, passes and other things. Okay, so big idea number one, just to give you a high level, we write our own shaders. How many folks are familiar with shaders or have written some? Okay, about half the audience, maybe new for some, but basically a shader is just a tiny program, or I guess it could be large sometimes, but usually tiny, that does a specific work or task, either individually or perhaps as part of a pipeline on our GPU. And the idea is that it could be highly parallelizable. So with the SDL GPU, we write these shader programs that build out our graphics program. How we move the quad around, for instance, happens in the vertex shader, moving vertices. How we paint the pixels happens in a vertex shader. So that's how we fill in the actual shape. So we have to write those little programs and provide them and basically build our own graphics pipeline. And the shaders in the SDL GPU API use this thing called SPUR-V, which is basically we take these shader programs and we compile them down into a binary, this intermediate representation here. So this from this specific shader language, which looks a lot like C, into code that executes on the GPU. Okay. So if you know GLSL, the OpenGL shading language, or HLSL for DirectX or Slang, or all these languages that are popping up, they can all compile down to the same intermediate representation, and you can use them within the SDL. Okay, so that's big idea number one. We've got to sort of program this pipeline that our GPU understands. The second idea is buffers. Okay, so what's the idea of a buffer? Well, buffer is just a chunk of data that, well, when we're writing these tiny programs on the GPU, that's what they access, these buffers of data that we'll upload to the graphics card. Now, we actually already saw one of these in the old SDL render texture. A texture is just a buffer of pixel information, okay, that we've uploaded. So the idea with the SDL GPU and all the modern graphics APIs is we've got to create specific buffers where we want to place data. What type of data? Well, maybe vertex information, position information. It could be just whatever chunks of data you want to upload. It could be pixel information and so on. So we've got a function for doing that, for creating the GPU buffer. And there's also some ways to modify the data as well. But basically, this is a upload the data, the shape of your 3D object, all the vertices that make it up that 3D object, and so on. That's the idea. And here's sort of what it looks like in code. Again, don't have to really read this, but the idea is you can add, here's your chunk of data. In the top box, I just have a bunch of vertices. And in the second box, I have setting up that buffer that says, here's where my vertices are, here's how many, here's how they're arranged. They have an X, Y, and Z position, maybe these colors, and so on. So that's the information that I'm uploading. Okay, so there are a few steps there that I have to do. And ultimately, this is going to get us a quad, 2 triangles smashed together to make a quad or a rectangle. All right, big idea number 3 here. So when we actually want to do some work, like draw that quad, what we actually do is encapsulate or say, okay, here's the work that we need to do to draw a quad. Here's the quad that I'm drawing. Here's where I'm going to draw it. So on the actual screen, what information I'm going to record. And we basically, again, put this in a buffer that's a series of commands. Now, SDL or other older graphics APIs like OpenGL were doing this for us, where you used to be able to just call functions one at a time, and then your driver would sort of populate and say, okay, this happened, this happened, this happened, this happened, and now I'll take some action. Well, now we're doing that job. So it's more work, but we can do it more efficiently. We have the actual commands that we're doing, so we can often do them in a more concurrent way. So that's why, or the reason why this style of API has sort of emerged, okay? But it is sort of 3 steps, okay? So again, we write our shaders, we populate our GPUs with some data, and then we say, okay, what do I want to do with that data, and which shaders am I executing on that data? Okay, that's what goes into the command, okay, at a high level. Okay, and let's, I gave a spoiler, I already showed our image here. But let's run it anyway here. So I've got an example here. I just want to show you a few things here. So SDL GPU example. I'll run the program here. So there it is. Hello. Here's a quad or a rectangle. And once I can draw one, I can just repeatedly do this, right? I can draw 1,000 quads, and then I can start writing different shaders to fill this in with pixels and so on. But that's the sample that I'll leave you provided with. In this folder, you'll also find the shaders for filling in the pixels. I usually call that a fragment shader or a pixel shader, and how to work with the geometry. In each of these shaders, these text programs have to get compiled into that SPIR-V format. So I use this thing called GLSLC, which is a shader compiler for that. Okay. And all those commands and so on are in the top of that image if you want to check it out later. Okay, great. So SDL GPU is one of the big features added to SDL. It adds, again, the ability to control the graphics pipeline by controlling what vertices do, fragments do, or if you're not doing graphics work and just doing compute work, there's also compute shaders, okay? And that's a really nice thing because if you're still using like an older graphics API like OpenGL, compute's not available on Mac because I stopped it at version 4.1. But now you can just use this, and again, you at the least have vertex shaders, fragment shaders, and a separate compute pipeline, which I think is important, and as kind of where we'll get to here. Part of the future of computing will be doing things on GPU and CPU. Okay. Great. So we went through this SDL3 library. You can use it. You can start making games. You can do some cool stuff. And one of the questions is, should C++ have a graphics library like this, right? Maybe it's the abstractions. Maybe it's grabbing a chunk of it. Maybe it's just the compute chunk. Personally, what I want is just the ability to place a pixel. That's good enough for me. But I think looking at SDL is a good thing to do, or a good example, maybe API we can look at, especially with the SDL GPU abstraction that's been added. We've seen various versions of that. We've even had some talks here at CppCon about writing C++ code that gets compiled into SPIR-V, right? So it just looks like C++ code and executes on the GPU. So whether that is for a game or graphics pipeline task, or maybe just a compute task that you could think of. So, it's something I'm thinking about. Lots of others have thought about. I tried to collect every proposal I could find recently-ish, going back a decade or so. And maybe, folks are in the audience who've worked on this, they can speak to it or their thoughts. You notice there's a, I'm not saying any names, but I support it. But it is at the interesting to read through these, see what you would have, or even if you're going to build your own graphics library on the side, right? See what's in these proposals, what are the commonalities, and so on. So anyways, and I would personally, right, if we can do this with Thread, for instance, right, which, is implemented on top of, OS specific, maybe pthread or whatever, Windows has and so on. Why can't we do it for graphics? Okay, maybe you have to get, why not? I'm sure there's many, I could come up with reasons, but, we certainly could do this. So anyways, I think it'd be very powerful to be able to just plot a pixel like this, right? You could basically sit down after watching this talk, look through these slides and build a small game. So why couldn't we just do that with a library in C++? That's a dream for me, especially as an educator. So anyways, I'll leave that to there. So there's lots of resources for SDL. I already gave a bunch. The wiki's awesome. It's always updating. That's just about how to read some of these pages. I do want to save time for questions, but hopefully you've learned something or got excited about at the least checking out SDL3, even if you were a previous user and are on 2. I think 3 is a cleaner API. And the GPU API is really neat, I think, especially if, I'm still kind of intimidated of these Vulkan libraries and so on, so I kind of like working here. It's a lot nicer abstraction. And then when I do decide to fully commit to those, I'm probably just going to end up building the same abstraction layer anyways on top with these. So at least you'll have a reference point, right? You can always kind of bounce around where you want to work. So anyways, thanks for your attention. I'll leave a few minutes for questions. And grab the slides and the code. Yeah, a couple of questions coming up. Yeah.
Okay, thanks for your talk. Is this on?
Yeah, I'll try to repeat if it doesn't.
Okay.
Okay.
Yeah, now it's on. Yeah. Text rendering was a bit clunky in SDL2. Is this better in SDL3?
Pardon, I didn't catch the first part.
Well, text rendering was a bit cumbersome. You had to create a surface, and then you had to render text on it with some properties, and then you could use it.
Oh, yeah.
So I'm a teacher too, and students struggle with okay, we need to update the text, and it was a bit difficult sometimes.
Yeah, so a few answers to that. There is still the SDL TTF library, but one of the best features, maybe one of the reasons to update to SDL3 is there is a SDL_debug text, and it'll just write out text.
Okay.
On the screen. So you can just kind of use that for debugging and set the size, and then not have to create your own bitmap font or something. Right. So yeah, it's awesome to, there's a lot of little additions like that.
Okay, thank you.
Yep.
Thank you for the nice talk. So with SDL, you have to do everything by yourself, but it's a nice API you can hook onto to do some stuff. Is there a minimal engine you can suggest, or what do you have experience that works? So that does something like camera management or so that I don't have to implement by myself.
Yeah. That's a good question. So right, as soon as we start getting into more, so other libraries that I would add on top of, let's say we get to the quad, right? And we want things like camera and so on. So I was just mentioning so GLM tends to be the standard like math library to start abstracting on top of these things. And then there's RayLib libraries, which also have math, and I think some, they might have a camera API, but I don't know if that's attached directly to this. So I don't know any offhand. I mean, there's certainly other engines. There's other engines too that basically are also thin wrappers on top of the graphics APIs, like Diligent Engine's one that comes to mind that also might be taking a look at. I think that's open to some degree. So you could try to see if you can just pull out the camera or some components from there. So yeah, there's certainly pure like graphics engines too, like Ogre 3D or Wicked 3D and stuff that you could plug in to some degree here. Yeah.
Okay, thanks.
Those are their own separate things, but then you could have the SDL handle all the input and all that stuff. Yeah.
Okay, thanks.
Yep.
Hi, great talk, thanks.
Yeah, thank you.
Just a question about SDL3 when you showed that demonstration of the animated character.
Yep.
When you create a window, it creates a buffer of a certain size, say 800 by 600. When you scale that window, the image scales with it.
Yep.
Is there any way of making it not do that and just dynamically increase the surface size?
Yep. Yeah. So there's something here.
I did try it before and I couldn't make it do it. And I did ask on the forums, and at the time, it might have been with SDL2, but they said no, it couldn't be done. We weren't going to support it. So. Oh,
I see. Yeah. I mean, you can always, so there's a few answers. You can always get the background surface or the texture with the window and sort of, resize it that way if you want like a callback to handling the event that's, whatever window resize and do that and so on. This, I would look at, the functions that I used for this were on the logical presentation setting. So there's a few there that you can kind of toggle around because, this is scaling dynamically, but it must be resizing.
I think I managed to get it where you could resize it. It would scale, and then when you let go of the window, then it would resize.
Oh, I see.
But, like on a normal Windows application, you want to scale it as it scales, but or you want to size it without. Yeah,
nothing that I know would do like a nice snap or something. You probably have to, just keep your own state and have it snap. Yeah.
Just this more of a comment. You mentioned, I've been using C++ for nearly 30 years, and I like you, I can't understand why 2D graphics, the sort of basic foundation of 2D graphics and networking as well, why they're not part of the standard.
Yeah.
There's so many people in C++ focusing on the language. And it seems to me that those two things are so ubiquitous that they should be in the language, and I think not having them holds it back. Anyway, that's my opinion. A bit opinionated. I'm sorry about that.
I mean, thank you. I mean, I started in basic programming, and I remember doing the mode 13 or whatever at the top, and just being able to put pixel, and so I miss that. But I mean, I understand why to disagree. But sorry, your question.
Yeah, thank you for the talk. Very nice. So when you started showing this presentation, I mean, all these. C interface kind of begs to be wrapped into C++. And it was disappointing when you said, well, I had a texture and it's not a good idea to wrap it in a class because, and can you repeat the reasons why?
Yeah, so I want explicit control over the lifetimes. So for instance, if I'm creating this world, like when I create this particular character that's running and you can see the like surface or the texture below, the only time I really want to free that resource is when maybe the game scene has ended. But if I want to, create another character, it's very easy if I can reference that same memory. So I don't want to worry about if it's going out of scope or not. So, I mean, you can certainly wrap this and maybe it's fine, but usually I just have one layer of abstraction on top of that, which is my resource manager. It says, free all resources or free this particular one.
But it's because you want like a big block of memory for all the textures or because you want to cache them? They're slightly different.
For the caching, specifically in this example I'm thinking about, if I have a big block, I mean, that's another thing too, right? As I draw more sprites, right, this is just one example. Usually you'd put those all in the same texture, texture atlas or sprite atlas, there's different names for it. Yeah. And then, you would want that to live the whole program anyways. Yeah. But the point being that you want control over when stuff starts and ends.
I had the impression that a combination of a pool allocator and some data structure can replace this manager kind of thing that, in my opinion, can also block to be standardized, because there are going to be like custom containers that we don't like in standard. But if we can put things in some kind of data structure that is friendly to this, that looks like SDL data structure, then in combination with scope allocators, whatever,
Can I actually comment on that?
Sure, yeah, go.
What I do a lot is unique pointer with custom deleter.
Yeah.
How I'll try to get around that, right? Like kind of keep a stable interface.
Yeah.
With SDL, but also have that like automatic cleanup.
So-
I find that to be helpful.
Yeah, so the comment was unique pointer, and you can add a custom deleter on it. That's one way to do it. There was a back to basics talks too about writing custom allocators, and exactly what you said, pool allocator, stack allocator. And in games often, you have multiple like allocators for like the frame that's going to do the cleanup. And that's a great use case for like, just clean up stuff that pops up and so on. Let's see, I think we're going to waive that for time. I'm happy to stay around for questions as long as possible, but thank you again.